The intermediate value theorem. Let f of x be a polynomial function. Then, if f of a and f of b have opposite signs, here's what we know. So let me draw a picture of this. So we have a polynomial function, which we know is smooth and continuous. And here's a, and here's b. And we know that f of a and f of b have opposite signs, meaning one is positive and one is negative. Now, because we know that polynomials are smooth and continuous, if f of a and f of b have opposite signs, that means that the polynomial has to cross the x-axis somewhere between a and b. In other words, f of x has a root, or in other words, a 0, in the interval between a and b. So that seems like a common sense kind of conclusion. Let's see what kinds of questions we can answer with the intermediate value theorem. Using the intermediate value theorem, show that f of x is equal to 7x to the 5th minus 9x to the 4th minus x squared has at least one real 0 between 1 and 2. So let's find out what f of 1 is. F of 1 is 7 minus 9 minus 1. In other words, that's negative 3. F of 2. Now, I'm not going to, oh, maybe I probably should, but I don't have a calculator with me, so I don't want to. But anyway, we would fill in a 2 for x where we see x, all right? So why don't you go ahead and find out the sign of f of 2? But I'm betting that f of 2 is going to be positive. So if we do that, what that says is here we have 1 and here we have 2. We know that f of 1 was negative. F of 2 is positive, all right? And the polynomial is smooth and continuous. So it has to have at least one real root between 1 and 2. Why? Because f of 3, f of 1, and f of 2 have opposite signs. And by the intermediate value theorem, there has to be a root between them. Finally, if we want to graph a polynomial, it's pretty easy. We just use technology, but knowing what we've studied about the graphs of polynomial can help us use our technology better, like how to set the window better, how to interpret what we're seeing. Given the graph of a polynomial, can we find a formula for the polynomial? So that's the last topic in this section. So let's see if we can find a formula for this polynomial shown here. And the way we're going to do that is by thinking about the roots and their multiplicities. All right, so this polynomial has a root at x is equal to negative 3. In other words, x minus 3 is going to be one of the factors. And it's going to be just a single power because it's a multiplicity 1 root. Let's take a look at the second root. The second root is 2. So x plus 2 is going to be a factor. Now notice that 2, at that spot, the polynomial bounced. It didn't cross the axis. So we know this is going to have an even multiplicity. We don't know if it's 2 or 4, but let's just put in a 2. Okay. And then finally, the third root is 5. That means x minus 5 is a factor. So let me go back and fix this here. My signs are backwards. So if negative 3 is a root, then x plus 3 is a factor, because if you solve x plus 3 is equal to 0, then we get a root of negative 3. If 2 is a root, then that tells us that x minus 2 is a factor, because if you set that equal to 0, that would give you the root of 2. And finally, if 5 is a factor, if 5 is a root, then x minus 5 is a factor. And notice that at 5, we simply have a root of multiplicity 1. And so putting those factors together with their multiplicities means that here is a polynomial which could have that graph that's shown here. Why don't you try this one? So again, One more thing that we can talk about is the power of the polynomial. But let's just go ahead and use the roots. So this one's going to have a root at -1. So let me help you get started. That means that x plus 1 is a factor. Think about what multiplicity it should have. Another root comes at 2. Another root comes at 4. So see if you can fill in the other factors and an appropriate multiplicity for each one. And that's the end of this section.